Hey everyone, we're going to use the principle of mathematical induction to prove this statement is true. That the left-hand side equals the right-hand side for all, and I'm going to write it this way, for all integers, positive integers. So that's for all n that belongs to the positive integers. That's double Z. All right. So the first thing you have to do is there's two steps. The first step is step 1, and we want to show that the statement is true for n equals 1. So that means when I plug in the sum here, if I plug in 1, and this is your first term here, so this is your n part, but if I plug in 1 into these two, because this is your end result, you get 1 divided by 1 times 1 plus 1. And that should equal 1 divided by 1 plus 1. And both of those equal 1/2, which is our first term. So that's true. And that's all you have to do for step 1. But I want to do, before we go to step 2, is go ahead and look at with n equals 2. What does that mean? Well, for n equals 2, that means the sum of the first two terms here. So I'm going to plug in 2 into this. So you get 2 divided by 2 plus 1. That equals 2/3. Well, that should equal these two terms added together. So that should equal 1/2 plus 1/6. Well, 1/2, this is 3/6 plus 1/6 equals 4/6, which equals 2/3. So that is true. So for n equals 2, it should equal the first two. If you plug in n equals 3, it should equal the sum of these first three terms, and so forth. But you don't have to do all that. I just wanted to show you what the reasoning is behind it. So we check for n equals 1. You have to show your work on that. So we're just going to put 1 is 1 plus 1, which equals 1/2. 1/2 equals 1/2. Now, for step 2, there's two parts. So step 2. Step 2 is you're going to assume that it's true for some n equals k. And then prove that it's true for n equals k plus 1. So this is like your A and B part of step 2. So for the assumption part, you're just going to write this out, but replace n with k. So your assumption part, that's going to be 1 divided by 1 times 2 plus 1 divided by 2 times 3. You should add another one. I'm just going to go ahead and simplify this. Usually you write 3 terms, especially if the first term is a 1. But our first term is 1/2, so we can kind of skip that a little bit. And then so everywhere there's an n, put k. All right, so that's our assumption. And then our proof part is prove that it works for n equals k plus 1. So that means everywhere there's a k, you're going to put k plus 1, and you need another term. So what I mean by that is you write this out again. Now, so for this, you just copy this first part down. So that's our first sequence. Now the next term is going to be 1 divided by, and we want the next k. So do you see how on the first k, it's 1, 2, so we're just adding 1. So the next term is k plus 1, and this one is going to be k plus 1 plus another 1. So it's k plus 1 plus 1. So it's k plus 2. And this should equal, and on the sum part, you write k plus 1 divided by k plus 2. Because k plus 1 is the next term, and then the next term after k plus 1 is k plus 2. So that's what we have to prove. Now, just keep this in mind. All of this part here equals k divided by k plus 1. So that's what I'm going to write on the next slide. So for the next slide, I'm going to write all of that equals k divided by k plus 1. And then our next term was 1 divided by k plus 1 times k plus 2. And our final summation was k plus 1 divided by k plus 2. So again, this first part was just this part with the k, because that's what that equals, and then we added that new term, and then we had to change the sum with the next term. So now we have to make the left-hand side look like the right-hand side. So here we want to get our common denominator, which is k plus 1 times k plus 2. So for this part, what's missing is the k plus 2. So all we're going to do is write k and times k plus 2. Again, all you're doing to make the common denominator, if you put a k plus 2 here, you have to put it here. Okay, and then we have our plus 1. Now simplifying this, we're going to get k squared plus 2k plus 1 divided by k plus 1 times k plus 2. Now let's factor the numerator, and if you factor the numerator, you're going to get k plus 1 times k plus 1, or you could write this as k plus 1 squared. And divide this by k plus 1, divide it by k plus 2. Now what happens is these two cancel, and you get k plus 1 divided by k plus 2. So after simplification, it does equal the right-hand side. So that means we proved that it works for n equals k plus 1. And that's it. Thank you. Have a nice day. Bye-bye.